Welcome to the AWS IoT Windfarm. This demonstration shows an industrial use case operating on the edge to assess safety of a wind turbine. The demo includes multiple ways to ingest the data, process it, and ultimately visualize it. What you see is a 3D printed wind turbine that has several sensors and an actuator added that are connected to AWS to demonstrate a serverless wind farm architecture. The wind turbine has sensors that measure rotation speed, power generated, temperature, and vibration. An indicator lamp is on top that provides insight into the state of the turbine, and there is a servo that acts as a mechanical brake to stop the turbine if a safety condition exists. The turbine is connected to a Raspberry Pi with a custom shield that interfaces with it, and this is our IoT thing that is connected on the edge to AWS Greengrass, which is running on a second computer. Greengrass provides an IoT gateway that can relay IoT messages that are published to other devices at the wind farm or to the cloud. It can also support a local IoT shadow service that helps relay messages that reflect the state of the wind turbine brake. Additionally, Greengrass can process data that is published on an MQTT topic using local Lambda functions. And in this demo, a Lambda function is used to evaluate the turbine vibration and speed data with a machine learning model. Based on the isolation forced algorithm, it assesses safety and determines if an anomaly exists that should be acted on by issuing a command to apply the turbine brake. If so, then a shadow update to the respective wind turbine is requested and the device acts on that to apply the mechanical brake. This happens all on the edge without a real-time dependency for cloud connectivity. The system is configured in the cloud and then deployed to these connected devices to run on the edge and assess safety and filter data locally. The Greengrass device also has a simple weather station attached that uses a local Lambda function to read the wind speed from the sensor connected to the GPIO header. Weather and wind turbine data both are also published to the cloud when connectivity exists where further analytics and visualizations can be done. To monitor what's happening at the wind farm, a few examples of data visualizations are shown. The first uses a third-party tool called Node-RED that is a registered IoT thing on the wind farm that subscribes to data from the turbines and shows a dashboard that can be accessed on the edge. For the operations team that needs to continually monitor the wind farm, the turbine and weather data is received by the AWS IoT Core service and processed by the IoT rules engine. The rules provide an opportunity to filter the data if we wanted to, but in this demo, all the data is passed to an Amazon Elasticsearch cluster continually as it arrives. There, a Kibana instance is available that provides the capability to view custom dashboards that can auto-refresh as frequently as every 5 seconds. There's also the option to have the rules engine direct the traffic to a data lake using Amazon S3. To do that, the data is directed to the Amazon Kinesis data firehose service where two things happen. The data stream is configured to batch the data into files every 5 minutes and also perform a transformation of the data from the original JSON format to a CSV format. To do that, a Lambda function is configured to work with the firehose data stream to perform that transformation on the fly as it streams through the service. The data files are then written to a S3 bucket in our data lake. Other periodic executive reporting and dashboard needs can then use the data in the data lake with the Amazon Athena service. Athena provides a schema on read capability with ANSI compliant SQL U-Write that queries the data in place from S3. Athena is compatible with another visualization tool called Amazon QuickSight. This tool provides an interactive dashboard experience that can leverage data from numerous data storage services and databases. Let's turn to what else can be done with the connectivity we have with the wind farm. Voice interaction using Alexa for Business lets you use common Alexa devices with a private skill that securely interacts with the wind farm to get the latest stats and perform command and control functions. This is done using AWS step functions to invoke several Lambda functions in a fan-out pattern that each gather different pieces of information from the system. Amazon DynamoDB, for example, has a cache of the latest turbine and weather data. AWS IoT Analytics provides the recent trends. Let's see how this works. Alexa, start Windfarm Demo.
Welcome to the Amazon Web Services Windfarm Demo. You can check wind farm status and control certain turbine functions.
Status.
The wind farm is online with one active turbine. The current wind speed is 5.0 miles per hour with an average of 6.0 miles per hour, and the safety brake threshold is set to 600 revolutions per minute. Is there anything else I can help you with?
Turbines.
Which turbine number?
1.
Which of these actions do you want to take? Status, apply brake or reset brake?
Reset brake.
The brake for turbine 1 has been reset.
The resetting of the turbine brake was done by invoking a Lambda function that requested a state change to the turbine device IoT shadow. That request was received by the IoT Core service and relayed to the Greengrass device on the edge. Greengrass then forwarded the request to the wind turbine device where it was acknowledged and the brake mechanism reset. Another interesting thing we can do is view the virtual twin of this turbine in our AWS Sumerian service. Sumerian provides a browser-based augmented and virtual reality capability that we can interact with. In the demo, the CAD files for this turbine were arranged into two assemblies, the mast and the turbine blades. Sumerian connects to AWS IoT Core to retrieve the turbine shadow that has the brake status, and it also continually fetches the latest turbine stats with rotation speed using Lambda. The blades are then animated to approximately match the rotation speed of the turbine in real life. Other data is overlaid in the panel, and you can move around and view the wind farm in different ways. This is a very basic example of a digital twin experience, and there's much more you could do. To round out this demo, I've added a few additional methods for ingesting data. In situations where data publishing rates or payload size exceed the limits of the IoT Core service, Kinesis can be used. Because the turbine devices are connecting through Greengrass, it's easy to redirect the published data to an alternate topic that has a local Lambda function that puts the data into the Kinesis stream. I've done that using a shadow attribute to specify the data path that the turbine should use. This same technique allows the data to be published to IoT Core using the Basic Ingest feature. Basic Ingest bypasses the message broker and sends the data to the IoT rules engine for processing. This provides a lower cost alternative for ingesting data into the cloud where PubSub is not needed. Finally, it's important to note the use of IoT Analytics in the demo. Two channels exist that receive weather and turbine data from the IoT Core service. Data pipeline processing makes it easy to transform and enrich the data. Data sets are continually rebuilt on a set schedule every 15 minutes to aggregate the data which is used to provide the recent trends at the wind farm. This is the data we heard earlier in the Alexa for Business demo. Additionally, on-demand data sets are created that are used in Amazon SageMaker notebooks to build and train ML models. I was able to quickly define my criteria for the training and test data using SQL and then load the data into Jupyter notebooks with a few lines of Python code. From there on, it's just like any other data you might have loaded from S3. The model artifacts can be deployed to the edge using Greengrass along with a Lambda function to make use of it where ML inference is needed. Well, I hope you enjoyed the demo and learned something new about AWS IoT and serverless architecture for industrial edge use cases. Check out the GitHub repo for this project that has all the hardware and software details, and thanks for watching.